Okay, so we're looking at constant acceleration model, unbalanced force model, worksheet 1. Okay? It's not something you have out right now, but you do have it. You did 1 through 5 ABC. Okay? And if there were, just happened to be a person who had the kind of markers like the ones that I love, I would love to borrow a couple because all I have is hot pink. Yes, may I? Do you need them? Get a couple for yourself. Okay, so here we go. Thank you so much. Oh my goodness. That's like a plethora. Okay. I want to go back for a second, just for a second, and make sure, since you guys didn't get the F equals MA derivation, but you just watched it online, right? Are you okay with that? Moving forward? So it's F net equals MA, or you can also say sum of F equals MA. Both of these mean the same thing, and they mean all the combination of all the forces together, okay? Great. All right, so back here, I'd like for us to do the free body diagram, and let's just do it. All right, I know you've probably already done it, but I want us to do it together. So what have we got? What? Okay. So FG on car by Earth. All right, what is FG? Let's just come down here and remember our model. We were doing some going over the test for test corrections this morning. What's the model that that sort of relates to this? Can someone say, perhaps Nicole? Right, times mass. Times mass, okay. And how would I say someone volunteer? What would be the for every statement here? For every, somebody. For every 10 newtons of? For every 10 newtons of force, there are 1 kilogram of mass, right? Okay, so that's great. How else could I write this? FG equals, how else could I write it? Anybody know? What symbol could I put for this? G. It's a lowercase g, and it means the gravitational acceleration of the Earth, and I could put an M here. And frequently, it's written like this. Okay? So frequently, we substitute for FG, mg, mass times the gravitational acceleration of the Earth, which is what? 10 newtons per kilogram. Yes? Okay, so I want you to know that. All right, back to here. All right, so we were going ahead. If you've answered, please don't answer again. I'd like to hear somebody else for a second. All right, let's go. What's up here? Normal on what? Car by surface. Is that cool? Or whatever, yeah? Okay, what else have we got? F push, okay. So I'm going to say F push on car, what? By engine. All right, and then back. Now here's where we got to be careful. Who say it? I heard it. Force friction, but let's look up here. So the car accelerates. What does that mean? Constant velocity or changing velocity?
Changing.
Okay, so changing velocity. And changing velocity means balanced or unbalanced forces? Right there, yeah? Timely. Okay, so if it is changing in velocity and there is an unbalanced force and it's going from rest to some speed, I have neglected to draw a diagram, right? So I could have my car, yeah, and it's at rest, so that means V naught equals what? 0 meters per second. It has some acceleration, doesn't it? Tells us it's accelerating. To some final V of some value which we know, yeah? We know that final V. Okay, there we go, on the screen. On the screen. Okay, so, okay? Yeah?
Yes.
Say yes.
Yes.
Right. So, I guess the reason I ask you about all that is which of these, since we say the forces are unbalanced, which of these forces do you think should have a longer force vector? The push or the holding back force? The push. So Lauren said friction, right? So I'm going to make it shorter, and I'm going to call it force friction what? On car, by, and I think I'll say ground, surface, whatever. And this is the one that's kind of traction, right? And I think the thing to think about is, what would happen if there were no friction? Let's think up something that would be no friction. Ice. So if it were totally ice and you were in the car and you hit the accelerator, what happens? The wheels just spin? Yeah, does that make sense? So there has to be some friction to grab onto to have traction. All right, so we're cool here? Okay, something I want you to do is I want you to to show the net force on your diagram, okay? So in what direction is the net force? So can you tell me? Right, left, up, down? Right. So on these diagrams, I want you to show the net force. Right? That equals the unbalanced force, right? It's unbalanced in that direction. Is that fine? Okay. I'd like us to move on to the graph. Can we do that? So on the graph, what have we got? What kind of graph is it? V versus T, yeah? So I'm going to say, hey, I kind of did I don't know how you did these, but I kind of did them by twos. So one of the things the AP exam looks for is that you spread your axes out and fill over 2/3 of the grid. All right, good? Okay, so did you do this graph?
Yes.
All right, so what I know is that in 20 seconds, so the whole time, I'm going to go from rest to 28, which I'm guessing 25 is here, so maybe kind of like, yeah? So I'm just going to take my Post-it thingy and put that in. Were you able to reason that out? Yes or no?
Yes.
Okay, so you're going to be asked every time to annotate the graph. Annotating the graph means that you do all these things we've done here, and you do slope and area under. All right, so the slope equals, what quantity does the slope of a V versus T equal? I heard it. It was tiny. It was a little tiny girl voice. Acceleration, yeah? And what value does this have? Do you know this right now? Right, meters per second squared, but do we know what the actual value of this is yet? No, not yet? Okay, great. So that looks like maybe the first question, maybe I. So we'll leave that out, okay? And can we find the displacement, which is the area under? So can we find that value? What is that? 1/2 base times height? What's the number for that? Tell me. Okay, do it. You have a calculator, code. Somebody besides Camille, get out your calculator. You don't want me to have to call your name out on the video for being a sloth. What you got?
Got 80.
Close but no cigar. Go again. 280. 280 meters is the displacement. Yeah? Is that cool? Great. Okay, so let's look at part D. I feel like we've done ABC well. Let's look at part D. List given quantities. So I want us to use, let's try using guess here. I think I'm going to come, I feel trapped by my computer papers. I'm going to come down here. I'm going to say maybe G, U, E, S, S. Okay? So what does this stand for? The given. All right, so what's given? Help me with the given. What's given? Right, so what does rest mean? V naught equals 0. What else? V final equals 28. All right, what else do I know? Somebody besides Eric. T equals 20 seconds. There's something else up there. Okay. Mass of the car is 1,500. Yeah? All right, what do they want me to find? Acceleration? Yeah?
Yes.
Okay, acceleration. They say average acceleration, but when you give the whole change over the whole change in time over the whole change in velocity, that's going to give you average acceleration. So acceleration. All right, so what equation could we use? I'd like us to come down here. Actually, I'll just go up here at the top and say, hey, we know, we have just learned for constant acceleration model, unbalanced force model, we've just learned V equals A. No, I want to write it like your equation sheet. Hold on. Okay, V equals what? V naught plus AT. Yep, we know that one, don't we? Say yes.
Yes.
Okay, we know X equals X naught plus V naught T plus 1/2 AT squared. Is that correct? Now, for both of these, you see little subscripts of X's on your equation sheet, and here's what I'd like you to know. All they want you to know, it's not because it can only be used in the horizontal direction. All they want you to know is that all these things have to be in the same plane. Okay, so if my velocity is in the horizontal, everything has to be in the horizontal. Does that make sense? If my velocity were in the vertical, everything would have to be in the vertical. Same here, okay? So there's one equation that comes from these two, and I'm not going to derive it for you, and I'm not going to make you derive it, but I'm going to give it to you and you can use it, and it is V squared equals V naught squared plus 2A X minus X naught. Okay, and this equation is special, so these are your big three, right? Big three, right? That's what these are. Okay, for what we're doing, those are the big three, and this one is special because it does not need time, right? So if time is not given, you want to look to possibly using this one, okay? It'll get you out of a bind. All right, so these are your choices. So what equation do you think you would like to use to find this A? The simplest way to get it. What do you think? Huh? Louder. I like it. V equals V naught plus AT. So so it says what? Substitute and solve. So I'm going to move this around and say V minus V naught over T equals A. And then what can I plug in? V, so am I starting from 0, right? So the truth is that V naught is 0, so that's going to cancel out, right? So I'm going to end up with what? V? 28? Yeah? meters per second over what? Equals A, so what's A? Oh, but I missed something. So it accelerates from rest to a speed of, no, I'm good, 28, right? I'm good. Okay, so 1.4 you said?
Yes.
What are the units? Meters per second squared. Great. So that's super great. And what does that tell me that I can answer now to annotate my graph? Slope, right? So 1.4 meters per second squared. Great. Okay, so what's the next question?
How far?
How far does it travel? What do you like? Big three, what do you like? Okay, I hear someone saying x equals, so let's see, this first one was I, was di up here. Okay, and this is I, yeah? Alright, there it is. So x, someone said x equals x naught plus v naught t plus 1/2 a t squared. And I think it's important that you remember that each term in this equation, it ends up being what? What sort of a value? Is it velocity? Is it acceleration? It's what? Each term. Well, that's a big lead balloon thud. So what is this measured in? What is this? This is displacement, right? Did we go through this and talk about how each term was measured in meters? All right, so this term is measured in meters, yeah? Okay, what about x naught? Meters. Okay, let's look at this. Plus meters per second times seconds. So what does that term end up being? Meters. You see that? Okay, what about meters per second squared times seconds squared? Meters. So all these terms mean meters, and here's the way this equation works, right? I'm going to say that this is the origin, 0 meters. And I'm going to say that the person, this is not about this problem, that the person starts here at 10 meters away. Okay? That would be x naught, how far you are when you start. Okay? The person is moving, right? The person has a v naught of 2 meters per second, right? So they're moving when it starts. Okay? So because of this initial velocity, they're going to cover some distance. Okay? I'm going to say that the time is going to be t equals 5 seconds. So because of this initial velocity, they will cover what? 10 meters. Okay? So 10 meters is how much they'll cover here. 10 meters is how far away they were to start. Yeah? So 10 meters, 10 meters. And then because they're accelerating, I'm going to tell you they're accelerating. All right? So maybe A equals 10 meters per second squared. So t squared would be 25, right? Times 10 is what, 250? Right, so because they're accelerating, they're going to cover another 250 meters. So in the end, their whole displacement is the addition of how far out they were initially, sometimes that's 0, how far they get based on the velocity they had initially, and how far extra they get because they're accelerating. So we add all the meters they were able to get their total number of meters for displacement. Yes, Jack?
Isn't it 1/2 times 250?
Oh, it is. It would be. Good call. So it would be 1/2, so it wouldn't be 250, but what would it be? 125. Way to make a good call. Thanks. Okay, so 125 meters, and we could add all that up, what, 145 or something? Yeah? Is that what it would be? So 145 total. Again, this little demonstration has nothing to do with the problem, so I guess I'll just take this out, and then we'll start I over here to the right. But I just wanted you to know that this isn't a mystery. This is total displacement, and this is how far you are initially, how far you get due to your V naught, and how far you get due to your acceleration. You add them all up, and it's how far you get. Okay? All right, so let's go ahead. Jack said, so Jack said, hey, let's try this for DII. So X, anybody already done it? Yeah, we wouldn't want to do that, would we? Woo! All right, let's do it. So we want displacement, right? So have we displaced any before the problem starts? I do not believe we have. We're starting from rest. The area is how far you totally displaced. Right, so when the problem starts, when the clock starts, does it say the car is 30 meters away from the starting line? No. So that would be an X naught. We don't have it. Things, guys, things that start from rest do not, by definition, do not have an X naught or a V naught. And know that if V naught is 0, 0 times T is what? 0. Yes? Okay, so that leaves us just with this. What's our displacement? Right, I mean, you did it by finding area, but I'm just showing you. So 1/2, what? 1.4, right? We already found that, yeah? What's the T? 20 squared. Does that get us what I think? Does it? Does it get us 280?
Yes.
Great. All right, so that's super great. All right, now the last part of this is forces. Okay, is everybody cool so far? The last part of this is forces. So what's the net force acting on the car? So I want us to we're just going to pick a totally different color to do the force stuff in, okay? So what's net force? What do we know? So I'm going to put this up as an additional equation that we have in our arsenal. F net. Oh no. This one needs to go in the trash can.
There's another one.
Okay, I'm just going to set that aside in sadness. Okay, all right, so F net, yeah, equals what? MA, right? But I want you to know our equation sheet. Can you look at that? Can you look at your equation sheet real quick, please? Because it reports it differently, and it's a way that I think is really going to make sense to you. Need some space here. Do you see it? Okay, so it reports it like this. Acceleration, how much something is accelerated, right, is equal to the push, yeah, the total push on their what? Okay, mass. Thank you. Thank you for the 3 people who answered. Appreciate that. Right? Okay. Why are you paralyzed? Are you just done? It wasn't personal to you. Okay. All right. So this is the way it's there. And what this says is how much you're accelerated is about how much push on your mass. Does that make sense? It's like our G is 10 newtons per kilogram, right? Okay. All right, so we've got that in the hopper. So they want net force. Can we do something with that? Find net force. Go. Go. Right, so this is D-I-Y-Y. Yeah? You do it.
So it's F net, and then it goes just over 15%.
2,100.
But we're doing acceleration.
So what does F net equal? 2,100 newtons. Nice job. All right, now IV says what if the coefficient of friction is 0.3 newtons per newton, what is the force applied on the car by the engine? So what we have to do is we have to say, so I'm going to put this down here. So let's see, we'll just say DIV. Okay? So net force is MA, but net force is also the sum of the forces. Can you look at your free body diagram and tell me the forces that are acting horizontally? So F net equals what? F push, and we'll make that positive because we usually take the direction something is moving when it starts to be positive on car by engine. Okay, now what?
Friction.
Huh? Friction? So what sign do I put here? Plus or minus? Minus force friction. Is that fine? How am I going to find force friction? So what does force friction equal? Force friction, what's our friction model? Equals what? Mu force normal, okay? And in this problem, what does force normal equal? Okay, I hear people saying the word gravity, and this is really important that you understand this. It happened in first period too. The word gravity means 10 newtons per kilogram. Fg is the force of gravity, all right? And that is 10 newtons per kilogram times the what?
Mass.
The mass, okay? So I want you to see this addendum, and I'm running out of space, so I guess I'm just going to have to do it on a piece of paper. So I'm just going to move over and I'll include this. That if we know Fg equals mass, oh, sorry, strike that. If we know Fg, right, weight, this is our weight mass model. Oh, thank you. Fg, all right, which is weight, equals 10 newtons per kilogram, right, times mass. That's our model we know. Fair? Okay, so it can be written this way. This 10 newtons per kilogram on the earth can be called G, and this can be called M, okay? G is gravity. If you use the word gravity, you mean this, okay? All right, and usually, traditionally, it's written like this, okay? All right. So I'm going to come back over here and I'm going to say, hey, because of my model, I know normal equals Fg. And because of what we just did here, I know Fg equals mg. Is that okay? All right. And you'll do it all the time so you get used to it. So now force friction equals mu mg. Force friction equals 0.3. What's m? 1500? Yeah. Times what? 10 newtons per kilogram. Yeah? All right, so what's friction? What is it? Help me. Okay, friction is, I agree, 4,500. Okay, so friction is 4,500. Okay, I really want to go for this and just fill in it. Okay, maybe not. Maybe purple. No, that's too big. Yeah. Thank you, though. Okay, so friction is 4,500 newtons. All right. So now, last one, fast one. Can I find the engine on the car? How can I do it? What's F net? So I know F net from up here. Yeah. Yes.
Yes.
Okay, so it's 2,100. So F net is 2,100 newtons equals F push, I'm just going to say engine here, yeah? Minus what? 4,500 newtons, yeah? So can you give me the engine force? Huh? Yeah, what you got? 66? Yeah. F push engine equals 6,600 newtons. Now, here's what we're going to do. Camille, can you come turn this off for me, please? All right, so we're going to stop right here. You are going to be asked to do 2 seconds. You're going to be